Hello, everyone. Great to be here today, and fantastic room. You know, this is my fourth automation fair, and the room gets bigger and bigger. So that's starting to be a challenge. So I want to expand on what Blake shared and double-click a little bit on some of those innovations that we have in the future of industrial operations. And really, because it's the first day of the event, and there is a lot of things that you will be able to see on the show floor, give you the opportunity to be curious and excited about some of those things, and just not stop the conversation today, but really go and see the teams and the different parts we have across the show floor to see in real those innovations I'm going to speak about. So this week is really about innovation. This week is about connections and the people we work with, and this is about imagining what's possible. I'm personally, and I'm the CTO, that's my job, I'm impressed about all the net new things we are able to show you this week. Blake mentioned AI, that's one of the elements, but that's not the only one. After me, Tessa is going to speak about production logistics. We have really a lot of very exciting innovations that we want to show to you. And innovations that are not a vague intention for the future that kind of surf on buzzword or these kind of things, but innovations that are real, practical, that solve real problems that you have in your operations. And innovations that we are able to show you in the show floor because they are real product that will scale to the right level to address different challenges. And with this moment in time that we have, I think we are really at an inflection point. And it's not just because of AI, but I think AI plays a very important point in this moment in time. We have seen multiple iterations of the Industrial Revolution. We have seen multiple evolution of automation. I think the automation, PLCs, whatever, as they are today, are very different what they were in the past, and they will be very different in the future. And that's what we want to be able to show you. But all these are evolution of industrial technologies that revolutionize industrial operations. And it's a lot about how people work differently as well. You know, Blake mentioned it in his introduction, and what we do at Rockwell Automation is really about can we help people maximize their potential? Can we really use technology to help people do a better job, whatever is their role, to be comfortable with the usage of technology, to deliver the right experience for this? So this is our inflection point. We believe there is a convergence of different technology that we are going to speak about today that creates the foundation for a revolution or a reinvention of industrial operations, combining different things. So where do we go next? I wanted to speak about a couple of points before I bring the rest of the team with me. So there is a lot of things to do around integrating machines, sensors, systems. This creates a lot of data-rich environment, but data is not sufficient. We need to do something about data. Otherwise, you just have a storage of data, and that's not what is going to solve any problem. We need to think about, as Blake mentioned, what is the right balance between what is at the edge versus what is at the cloud. It depends on the application, it depends on the context, it depends on the maturity of the customer. We want to develop solutions that have the optionality to address problems at the edge, in the cloud, or both at the same time when this is the right architecture. We don't want to constrain customers to use the cloud because it's fancy or to use the edge because this is where we are comfortable. We want really an hybrid cloud architecture that supports industrial operation and integrate in the right way in the enterprise environment of our customers, because let's say it as it is. Operation technology is a subset of the overall enterprise architecture of our customers. So the modern approach to automation needs to embrace those best principles that we have from IT, and we need to apply those modern principles to automation. So we look at all those ideas during Automation Fair, and you will see a lot of this. There is something that is very important to me and that is very important to the rest of the team here at Rockwell Automation is the ability to build trust in technology. Technology should not be frightening. Technology should not be a concern for people where they could think that technology is going to get them lose their job or is going to get them be irrelevant. Building products with technology in the right way, transparency, ethical practices, security, and human-centered design. All these technology are meant for somebody to be used in their work. Do we understand what that person is doing? Do we create the right experience that allows people to use this technology in an efficient way in their workflow without the need of becoming somebody that they are not. So how do we create a human-centered design that make using those modern, sometimes fascinating or frightening technology in the background? It's not about the technology, it's about the experience that we create and how we can have an impact with those different experiences. And at the end, I believe technology is not replacing people, but it's improving the way we work. We have a lot of conversation with customers where their main issue is that they do not have the right people to address the challenge that they want. They are looking for more people, so they are using technology to augment the people that they have and to be able to do something different, to improve the way they work with technology. So this is an inflection point where people and machine work together and bring this next level of revolution that is a revolution about human and technology equations. That's really the two things that goes together. It's not about trying to look at all those fancy emerging technologies that we have and be in awe about them, but how does those technology change the experience for people? How do we have an impact that is economical or sustainability related or safety related or security related? This is what matters for our customers. So that's really the inflection point we want to be able to speak about today. And what we really believe is that there is a future that is possible in digital operation, but a lot of this future relates to choices that we have to make today. What is the right data architecture for today, but for tomorrow? How does everything work as a system? Our products are not just a collection of individual functions. There are a whole set of things that work into a system, and this system is not just about Rockwell Automation. This system is made of our partners, their products, their technology. This system is made of open standards that we contribute to because we want to live in a world that is open and where our customers choose our technology, not because this is a trap, but because this is the right technology for the application. We want to feel free that they can live whenever they want, but they don't because they are very happy with what we deliver to them. That's really what we want to be able to achieve. And our vision for industrial operation is really all those values we have spoken about the past years and with all of you. Flexibility, agility, openness, simplification. I think Blake mentioned simplification as a very important point for us. I want to double down on what I said before on human-centric design. There is no way all those technology can have the impact that we expect if we don't bring the experience to the best simplicity possible, where it just works. You know, like when you use your phone or where you use some of the products that you think are great, why are they great? Because they just work. You don't have to learn about them. They just work. You understand how they work. It's intuitive. It's simple. It speaks to you and to your experience. That's what we want to be able to achieve. And our vision for the future of industrial operation is really using the power of digitalization and intelligence to really create a self-organizing, flexible production system. And when I say self-organizing, we tend to be historically on production system that were, well, they operate at a certain level of nominal performance, which is they are designed for this, but we know that the reality of industrial operation is different. There are a lot of variability in the environment parameters, in the input material, in the way people work. So how do we create a system that permanently adapts to those little changes and permanently optimize toward a business scenario that the customer has chosen? This is what we consider as being a self-organizing, flexible production system that we feel our customers are willing to embrace. So by combining automation, analytics, AI, and integrated robotics, which are really some of the things that we are going to speak today, we believe in a world that has those 6 attributes. Those are really the 6 core ideas that I want to be able to share with you. We believe in production systems that adapt to change in real time, not adapt to change because data are extracted, an expert makes an analysis, 2 weeks later gets back to production and says, this is what I found. No, this is adapting to change in real time. AI enables industrial autonomy. So when we say autonomy, that's a natural evolution from us, from automation to autonomy. Like a car can be autonomous and go from A to B, we want a production system to be autonomous in the sense where it gets to the business scenarios that you want to get, and you put the operators in the driver's seat to be really able to make the decisions that matters and leave to the machine or to the algorithm all those things that are not critical in terms of human decision. Really using human intelligence where it adds value, but not use human intelligence to repetitive tasks that could be done by an algorithm. Interoperability is very important. Seamless communication. When I say interoperability, it's not interoperability with ourselves. This is what I said before. It's interoperability within an ecosystem that we have chosen, within an ecosystem that we contribute to, and we create standards in this ecosystem. Like, for example, some of you might have heard about Project Margot, which is interoperability at the edge. Well, we pioneered that with some of our peers, competitors, to bring to the market a standard under the Linux Foundation that sets interoperability for edge applications so that this is not a debate anymore. This is something that we do together. Technology enables flexibility, agility, and openness. But doing those three things at the same time, there is an element of complexity because those things kind of contradict each other. You know, like you could be tempted to be, if I am close, then I'm going to be more optimized. If I'm more open, then I have more variables and more things that I do not control. When we need to find this middle point, but flexibility, agility, and openness with technology is very important. And at the end, I've said it before, so I know some people will smile, but AI gives people superpowers. This is what this is about. The success of AI in the ability to create tools, technology, experience, workflow, where people maximize their potential, really are able to bring the best of their knowledge, the best of themselves. They are not bothered by things that are not interesting, unsafe, dangerous, risky, dirty, whatever. But they really focus on the tasks that add value, and this makes jobs more interesting, more attractive, more exciting, and it helps our customers find the people that they need because this renews the appetite of working in the industrial environment. This creates a new type of attractivity. And then finally, and this is the conclusion of all this, really this idea is that people and machine working together reach their full potential. And their full potential that sometimes needs to be discovered. There is a lot of things that we can understand in terms of how do we elevate production capacity, how do we elevate quality, economic performance, agility, all those things. So it's going to come because we get the right technology on the market to have people and machine reach their biggest potential. Not just people working with people and machine working with people, but machine collaborating with people. And you are going to see some very interesting examples about this. So we are going to talk about this shift, and I will even call it reinvention, from industrial automation to industrial autonomy, because we believe it's a natural evolution in our business, and it's also something that we are very legitimate to drive because of our history, or experience, or domain expertise. It's not something that is completely crazy. It's something that we feel we can really drive. And there are three areas that we wanted to double-click today on. Is integrated robotics. I feel sometimes it's a little bit strange because in this industry, I've been in this industry for a long time, you kind of see robotics and automation in two different worlds that touch each other time to time. Well, this is changing. All what we do right now is robots and different form of robotics, AMRs that you are going to see, robotic arms, other things, are going to be a part more and more important on the industrial production. But not in a way like it was before, where robots or those type of equipment are isolated in their own environment, but really in a work where this is an open factory where machines and robots and people coexist together in a safe way for the benefits of the quality of production. We are going to speak about AI and kind of land a little bit AI from the buzzword to this is precisely where we apply AI. What does AI mean for our products? But also what does AI doesn't mean, you know, what really we want to focus on and where do we want to be the value. And we want to speak about software-defined automation because when we speak about system, the cohesion of the system and the architecture that is necessary, that's the thing in the background that you need to understand because I think this changes fundamentally the way systems are architected and the way they are future-proof. So those three things are fundamentally changing the way we address industrial operation. And I'm very passionate about those topics. I hope you can feel it in what I share with you. But I wanted to bring with me on stage the people that are living and breathing this technology every day. I wanted to bring to you really the A-team of those topics to share with me in a conversation what we are able to do and where do we see the potential and what we bring to the market. So let's turn our attention to robotics. And I would like to welcome on stage Matt Randall, who is the CEO of the recent Rockwell acquisition, Automotors and ClearPath Robotics. So let's welcome Matt Randall on stage. Welcome, Matt. Thank you. Great to have you here.
Thank you, Cyril.
No, I keep it. That's me. That's my responsibility. Okay, let's get started. So we think about robots a lot associated to the topic of autonomy. So, and it's a wide field. It's a mysterious field for a lot of people. You have been living in this in your professional experience that led to the creation of ClearPath Auto. Can you share your thoughts on what are the opportunities of robotics in a production environment? What do you see?
Well, for me, what I'm really passionate about is the opportunity to apply advanced robotics like autonomous mobile robots to elevate people in the workplace. Every once in a while, a technology will come around. Like you mentioned, AI gives people superpowers that fundamentally transforms human productivity. A very simple example that I like is an excavator. Right? If you think about the task of digging a hole, it used to take 20 people a full shift or a full day in order to execute the task of digging a trench. Now it can be one person plus an excavator in a matter of an hour to get the same job done. We see that potential applied in factories and warehouses using advanced robotics to amplify human potential. In particular, we're interested in the dull, dirty, or sometimes dangerous tasks that our people at times need to do. These are the tasks that are difficult to staff, and these are really the things that people can't, won't, or shouldn't be doing in the first place. We think the application of intelligent, advanced robotics can create safer and more productive workplaces, giving people superpowers at the same time. Back to my example of the excavator and digging a hole. That's a great example of a dull task. The motion of digging, lifting, and twisting is often prone to repetitive strain injury. It makes for a pretty harsh day on the job. The exact same motions are done time and time again inside of production operations for moving materials, packing boxes, picking up and twisting again and again. It leads to those same repetitive strain injuries. With the use of autonomous mobile robots, we can amplify how materials move inside of facilities, creating safer and more productive workplaces for our customers in the process. And in doing so, we're able to align our people to higher value and safer tasks. Things that people are better suited for: creativity, continuous improvement, quality control, things with their hands and their eyes and their ears and their brains that today you just would never be able to automate. This is what fuels us as humans, and we think by aligning your human workforce with your robotic workforce, you can create a more vibrant company in the community that it serves, which creates a more vibrant community and then a more vibrant local economy.
So what I hear you saying is, I will put this in the context of many conversations, not necessarily with customers, but generally in the environment. There is a bit of the perception that robots are going to replace people. You know, it looks like Terminator for some people, where the machines are going to revolt against the people and take control of the industrial space. I don't think we are seeing that. I think we are seeing a different type of equation, and I think we are seeing different needs from customers. What do you think about that?
Yeah, exactly right. I mean, we hear all the time from our customers that they can't find enough people to do the job that needs to be done. Manufacturers are struggling to fill roles. And if that problem persists long enough, you risk shutting down the operation. A Fortune 500 customer of ours in the Midwest came to us with a very big problem. They're operating a plant with 4 lines. One of the lines was down, running at 75% productivity because they just couldn't get enough people to staff the 4th line. With Auto, you're able to rejig how your people are stationed and tasked inside of the operation to get enough capacity to put that 4th production line back up. It's not about doing more with less. It's about just getting the job done with what you have. And the pressures that our customers are facing, they don't have enough in order to get the job done that's expected of them. That's where the human amplification becomes so important, whether it's advanced robotics or AI or some other advanced technology. When you can augment people, you can not only improve productivity in the operation, but like I said, focusing on the dull, dirty, or dangerous tasks, you create a safer workplace with higher value and often higher paid jobs for those people. That improves job satisfaction, and it also creates a workplace that people are attracted to, which can become a very important competitive advantage in today's incredibly competitive job market.
Yeah, so if we look at AMRs in that context, so we see this is gaining a lot of traction in the industrial space, and I feel, and we've discussed that many times, that it's more than just moving things around. I feel the opportunity in AMR is beyond just moving things around. It's something that can play a new role in an industrial facility. So can you elaborate on that a little bit?
Yeah, so in the case of autonomous mobile robots, we've got state-of-the-art sensors, compute, and software on board in order to autonomously move materials from point A to point B. But these same sensors can be utilized in many different ways. We have all of the ingredients on board our vehicles that each one is itself a data machine. And we're very interested in the opportunity to collect, process, and report unique new insights capable only on the heels of having AMRs adopted inside of a facility. When you combine a data machine like an AMR with a data platform like data mosaics, you're able to connect to insights that previously were not possible. You're able to figure out which part of your production process is holding you back in ways that you didn't even know previously. As a simple example, our auto vehicles will do pickups and drop-offs day in and day out, hundreds or thousands of times per shift. Each pickup and each drop-off, we collect information about what's happening upstream and downstream from the material handling task that's being asked of auto. Understanding where production bottlenecks are upstream and downstream is a very important insight in order to help you pinpoint where is your next continuous improvement sprint going to be focused.
Yeah, and a lot in industrial application is about finding the bottleneck, so that's really greatly helps on that regard, yeah.
Yeah, absolutely right. So this week we'll have auto on display on the expo floor. You'll be able to see these sensors and software computing the environment. We've got live maps, but we have a special guest today. I'm excited to talk about what ClearPath is doing to take data collection to a whole new level outside of the factory floor. We're going to do a little bit of a scan of the audience here. We've got a vehicle with the same types of sensors, but some additional data collection instrumentation.
If you had something to hide, it's too late, because it will see everything.
Yeah, we're going to do some anomaly detection in the crowd. If there's somebody in here not wearing a badge, Husky will find you. So I think we're going to put on a live feed, and you're welcome to wave if you see yourself on the camera. The organizers have promised me this is not a kiss cam, so you're welcome to wave. So whether it's an auto AMR in a factory or a Husky observer in a rail yard, we're combining advanced sensors with compute and software to connect processes and equipment to a data backhaul that just didn't exist previously. If you think about most industry, much of the infrastructure is legacy. It's disconnected. The gauge or the instrument isn't connected to the cloud. With a vehicle like Auto or Husky, you're able to take the instrument to the We've got a lot of connected phones in here. You're able to take your data collection to the point of interest that is not currently connected. So Husky today is being used in applications ranging from, I thought people were waving at me. That's why I was getting a little bit tripped up, and then I remembered there's a robot. Whether it's being used in a rail yard or in a solar farm, or one of my favorite applications is in a substation monitoring for hotspots in the power grid to prevent brownouts or blackouts for homes. To my favorite example, studying the migration behaviors of emperor penguins in the Antarctic. Husky is being used in all kinds of novel data collection applications outdoors.
So when we look at this idea of data collection, so pretty much we have a set of sensors on wheels, and that's really a fantastic opportunity to observe the environment, and as you were seeing on the video, identify safety violations, or identify issues, or identify bottlenecks, like materials that should not be here. Many things, mapping the factory so that it could be used in a digital twin. So that's really mind-blowing in terms of what are the possibilities. What are the opportunities do you see for AMRs?
Well, we talked about the core capability to transport autonomously, and then the additional data opportunity that exists kind of implicit on top. What's even further possible is when you intersect traditional industrial robotics with advanced mobile robots to create what we call mobile manipulation. So we're going beyond data collection and insights into action. One of the first applications that came to us, as you can see on the screen here, is a bimanual industrial robot mounted on an auto AMR to tend to a chemical process. So now we have a robot being able to interface with an environment designed for a very manual human machine tending process. Machine tending is such a great example, not only in Hero Tech. We had another large aviation company that came to us wanting to tend to very high value parts coming out of a large CNC operation. But the cost to put an industrial robot at every single CNC machine not only was prohibitive, but there just wasn't the aisle space in order to do it. So with mobile manipulation, you're introducing a brand new capability as it relates to autonomy, data collection, and ultimately action with a mobile manipulator. So Husky will be leaving the stage shortly with me. Husky will also be on display all week on the Explo floor. I welcome you to come check out both Auto and Husky during your stay.
So those are really great examples, and I think this is all in the spirit of helping people work differently, not doing the dirty, dangerous task, collaborating with a robot for some other activities, really augmenting people and empowering people with this technology on the show floor. So that's really a great example, and as you said, those are things that we show on the show floor. They are real things that you are able to see, touch, feel, and ask people questions about, because this is not innovation in the future, this is innovation today. So what's next?
Well, really, we're fueled by the question of what's possible. We want to embrace these technologies to simplify the work that we do. And we think that the combination of autonomy with transparency brought through data collection, turning into insights that we just previously didn't have available to us, to create safer and more productive workplaces. The combination of enhanced safety, productivity, and data-driven insights is what gives us that elevated workplace. And better workplaces, as I said at the beginning, create better communities and better economies, which is ultimately a win for us all.
Thank you, Matt. That was really great, and thanks for being with me today.
Thank you so much.
So an important underlying capability is that we kind of speak about a little bit with Auto is AI that we use in advanced robotics, but also the idea of closed-loop system and closed-loop optimization leveraging AI. So that's the second topic we are going to speak about, and I want to invite on stage Jordan Reynolds, who is Vice President in charge of AI and autonomy at Rockwell Automation. So let's welcome Jordan on stage. Welcome, Jordan.
Good.
So a lot of people are talking about AI. I think there is a bit of cloud of buzzwords and opportunities and flashy things. So I think it's important for everybody to look at some pragmatic applications. So let's share some example on how we are making industrial AI real. So not theoretical, not fancy, kind of fancy and cool at the same time, but real in terms of its impact.
Yeah, it's a great question. I think just to add a little bit of context, the first thing I would say is that AI and autonomy for us goes far beyond just an academic curiosity, right? what we're fundamentally interested in is the way that we can incorporate the functions and capabilities that AI brings us into the production functions that we serve to our customers within their production system, right? So you think about everything that we have at the sensing and actuation layer on the equipment, to the control layer, to SCADA systems and edge compute devices, to operations management systems, et cetera. What we're really interested in is answering the fundamental question of, if we could imagine these systems for the first time from the ground up, knowing that we could incorporate self-learning functions in their behavior, knowing that they could have the ability to generate complex instructions or information for customers, knowing that they can adapt as environmental conditions are changing, and knowing that they can solve complex optimization problems. How would we think about all of this differently? How would we think differently about sensing and actuation and control and operations management? And then, how do we create value out of this in every stage of the production lifecycle, from design through operate through maintain? That's really what we think about when we think about industrial AI.
Yeah. And let's look at this design, operate, and maintain to be practical in the different applications as it relates to each of those three pillars, but also as they relate to each other, because the real relationship between design and operate, between operate and maintain, and all those things are related. So let's start with design.
Yeah, that's exactly right. Design is a really important one. I mean, I think you can kind of imagine that a lot of the painstaking labor and decision-making process happens in the design phase, right? So, you have to figure out how to design the physical layout and the kinematics and the flow of a production operation. And then you have to figure out how to program the control logic for each unit operation. And you have to figure out how to optimize all these decisions and parameters and continuously improve them over time. It's a really laborious process. It takes a long time, and it's kind of standing in the way as a critical path from actually running production and making money, right? So when we think about the relevance of industrial AI, it starts with a digital twin for us. I think the digital twin is a really important ingredient. So we have a platform called Emulate 3D that does two fundamental things for us. One, it simulates the geometry, physics, and kinematics of a production process. But two, it allows you to emulate your automation logic, like your PLC logic, in the context of that simulation. So this is really valuable for doing what-if scenario analysis and solving really interesting engineering problems. But it's also a critical ingredient for a really good industrial AI strategy, because it serves as a training gym of sorts for AI agents and AI capabilities, right? This is really important. If you're designing a greenfield installation or upgrading a brownfield installation, you might not have access to large volumes of historical data to use as a training corpus for AI capabilities. But if you have a digital twin that's a virtual representation of how the physical behavior of the process, you can use that for AI training capabilities, right? And now we have to think about like the next step. So if I have a digital twin and I've laid out my design for a complex operation, now I need to write the PLC code for each unit operation in my production process, right? And this is where PLC programming emerges as another complex endeavor that we want to simplify, right? One of the ways that we're doing this is really exciting, is with our FactoryTalk Design Studio Copilot offering, right? So Design Studio is our modern, cloud-native, integrated development environment for PLC programming. And what we've done is we've integrated our own proprietary generative AI capabilities natively into Design Studio, so that rather than just manually or explicitly programming automation logic, you simply issue a natural language prompt, right? Like, write me a process that will automate this bottling procedure and take care of X, Y, and Z. And you give a prompt and maybe a set of objectives and constraints, and it just writes the code for you, right? And you can kind of see this in the demonstration video, right? So really phenomenal breakthrough in productivity enhancing capabilities with this type of technology. It's even more exciting when you bring these two things together, right? So if I have a digital twin and I've gone through my PLC programming process, I can now validate that that logic is correct and optimal in the digital twin, right? So what you can see here is a picture of a digital twin in Emulate 3D, but with the actual ladder logic integrated at the bottom. And if AI generates PLC code for me, I can emulate how that code is likely to perform, make sure that it stands up against all edge cases and different complex scenarios. And if it's good, I can validate it. If it's not so good, or if there's still room for improvement, this can operate as like a systemic feedback loop back to the AI capability to continuously improve it over time. So the more you use it, the better it gets at solving your automation problems.
So we looked at design, and I think there is a lot of great experience enhancement. We can create productivity enablers for developers. Let's look at runtime. How ML, AI functions look like in the context of runtime operation?
Yeah.
How is it different from the rest? How is it specific?
I think to answer this question, it's really easy to just look at adjacent domains and look at some of the really incredible accomplishments that we've seen with the integration of AI in sensing and control systems in areas like autonomous vehicles, autonomous mobile robotics, which we just saw, things like rocketry, unmanned aircraft. All of these things have some similarities in which they require complex advancements to the sensing capabilities and the control capabilities of the machine or the system, right? And what's unique about these is that many of these things are so complex that the sensing logic and the control logic can't be explicitly programmed. You need learning functions to determine the optimal behavior, right? So something as simple as like recognizing a human face, it's not something you can really program. It's something that you can only really do with machine learning functions, right? So when we think about how this applies to industrial automation, where we also have these really complex, multivariable, nonlinear control problems that we have to solve in manufacturing, we think about the way that we can incorporate this technology into sensing and control, right? So I'll give you a really good example of the way that we're incorporating it in the sensing layer to start, right? So at Automation Fair this year, we are announcing our very first machine vision system for quality inspection. It's called FactoryTalk Analytics Vision AI. We're really proud of this. We're really excited at how it's come about. But effectively, this is a neural network-based quality inspection system that leverages cameras that you can mount over a conveyor to inspect a product for defects. Now, the important thing here is that you don't just get a camera and have to code a bunch of rules that specify whether a product is good or bad. You simply provide it with examples of what good and bad looks like, and it learns the underlying logic to classify a part as good or bad, right? So this is really exciting when you think about the level of value that you can achieve in quality with AI capabilities integrated into the control layer.
Yeah, and I think this is really the differentiation with existing vision solution. It's not a system on its own designed for expert, but it's something that integrates with control and use the knowledge acquired through the vision system to impact control parameters.
Yeah,
that's really where
that's
it's
exactly right. Yeah, so once we have the ability to detect defects, now we have the fundamental question of what's causing this defect and what can I do about it, right? So I may train a model to recognize a defect in a product with a vision system. Now I have to train a complementary model to determine what parameters to manipulate in order to eliminate that defect altogether, right? This is the reason that we've introduced Logix AI and have evolved the product over the past few years, right? So what Logix AI does is it makes any control Logix PLC AI enabled, right? This brings integrated AI features directly into the control design time and the control runtime so that you can leverage machine learning functions to make predictions of process variables or to optimize your control strategy, right? Once again, when you put these things together, they become even more interesting, right? There's this kind of symbiotic relationship between sensing and control. If I have better situational awareness of the state of my process or my product from a vision system, I can pass that into an AI capability like Logix AI that runs in the controller to figure out exactly which manipulations to make and bring AI into an autonomous closed-loop production system.
Yeah, and I think something great examples here. I think something that is important to have in mind is we want to bring AI to existing architectures, to existing systems. We don't want you to buy a fancy new AI PLC or whatever, but we want to create an upgrade path from the existing technologies that you have.
Yeah.
And I think Logix AI is a great example because you take a traditional PLC and then you make it an AI PLC by adding a function in the rack. So we look at those great examples, but none of this matters if your equipments are breaking down or if you are not able to predict what will be the perfect behavior of your equipment. So let's talk about the maintenance phase, where there's been a lot of talk on the AI world for many years, but something that was very descriptive, like something that was very much, hey guy, your motor is going to fail, do something about it. And we want to do something different this time. So,
exactly.
Talk about it.
I mean, predictive maintenance has been really difficult for a long time. So first, in order to access the benefits of a predictive maintenance strategy, you have to sensorize your entire production process, vibration sensors, thermal sensors, et cetera, then you have to have historical data that tells you what was going on when certain downtime events occurred. And in some cases, you have to program rules that specify what good behavior and bad behavior look like, right? Well, this could really be simplified with more modern types of AI capabilities, right? So one of the strategic recommendations that we make to companies about predictive maintenance is start by leveraging the sensing capabilities that you already have on the factory floor. And a great example of this are variable frequency drives. So our PowerFlex drives, for example, they actually have really robust motor current sensors embedded in them because you need them to properly energize a motor, right? So we realized that by using the sensors that are already available in our drives, in our intelligent devices, we can create a capability called Guardian AI that just plugs into the VFDs and does an anomaly detection analysis on the motor current signature, which tells you what normal behavior looks like and also gives you the ability to identify abnormal or anomalous behavior, right? So this is a really powerful way of getting started with a predictive maintenance strategy without having to go through expensive and time-consuming sensorization efforts to get started.
Which I think is really the important point. It's this upgrade path that I was mentioning. You already have a drive. We can make this drive a sensor, a predictive maintenance equipment, just by augmenting it with a piece of technology versus asking you to purchase another drive that will have those specific functions. I think it's very important in terms of approach.
Yeah. And I mean, that's only part of the battle, though. I mean, once you have a better understanding of the condition of your equipment, you now have to figure out what to do about it, right? So do I need to plan a preventative maintenance procedure? When do I plan it? Like, when do I take down production in order to do that? What work order is required? What are the steps to facilitate that work order? Who should do it? What materials do I need? It's like this big, complex optimization problem that people generally have to figure out manually. And traditionally, computerized maintenance management systems, CMMS systems, have been used to make these types of decisions, but the challenge is they're oftentimes just a way to record the decision that you make manually as opposed to making these decisions for you, right? So one of the benefits of our Fix platform is that we've incorporated machine learning and algorithmic features into CMMS to actually tell you what the optimal maintenance management strategy is when you see a defect from Guardian AI. And you can imagine how these things work together effectively, right? You have your condition analysis from Guardian, and then you do your maintenance planning optimization within Fix.
So I think great example. I think we went through design, operate, maintain, and really on this idea that we augment our portfolio with AI, we augment our products, we augment your install base with AI, and we are able to create experiences that makes this easy to use in the process, in real time, in the factory environment. So thank you, Jordan. Thank you for helping us bring AI to the new level.
Thank you. Yeah.
So I think industrial autonomy that we discussed about has the potential to change the way we work. But the foundation of this is not just an accelerated compute, which is an element. There is always the feeling that AI needs more compute, but it's also a different compute. Where is it? How it is distributed? So we need a different type of flexible architecture. We need to look at our system architecture in a different way. And I want to talk about our approach to software-defined automation. And I want to welcome for this Dan De Jong on stage. So Dan is our VP in charge of control in Rockwell Automation. Welcome, Dan. So in all what we do, there is a tremendous amount of volume, value, velocity of data. There is a need of accelerated compute. There is a need of something else and something different for automation. But OK, let's address the elephant in the room. And you are going to speak about it. SDA is not just about making another type of PLC. If we were just looking at SDA as a virtualized PLC, well, you get the same old architecture with a more fancy product, I would say. So we looked at the architecture to embrace SDA and the principle of software-defined architectures all across. And this is what we want to share with you today.
Sure. Cyril, as you, Matt, and Jordan highlighted, past approaches to automation aren't sufficient for the future of industrial operations. Our next-gen automation technology is making the shift to SDA not only inevitable, but imminent. Automation engineers and designers, the brains behind industrial operations, typically start the design process after knowing what hardware is going to be used, things like motors, sensors, and PLCs. SDA flips the script. It starts with hardware-agnostic programming, leveraging modern IT tooling with copilots, version management, in the cloud or at the edge. The last step is to pick the hardware, and then, if necessary, change it.
So we speak about decoupling the function from hardware. So what is our unique approach to SDA? How are we thinking about it so that at the end we get what we want, which is something that is scalable? There has been some approach to software-defined architectures that just increase the level of complexity. It's hard to design, it's hard to maintain. So scalability, adaptability, resiliency, how do we do that? What is your unique approach that we have chosen at Rockwell Automation to address that?
Sure, Cyril. We've been in industrial automation and innovator for decades. One of the key innovations that we brought to the market was integrating disparate control systems into one control platform. We call this Logix. Many of you are well aware of it. Logix is really the essence of a multi-discipline control platform that's brought together discrete, motion, process, safety, batch, and many other things. Our approach to SDA is taking multidiscipline control to a whole new level, accelerating the speed to bring emerging disciplines to market. Things like robotics, what Matt just talked about, vision, what Jordan just talked about, AI and machine learning, and there'll be many more. Think about disciplines for this discussion. Think about disciplines using an IT term, workloads. With SDA, you'll initially see Logix becoming deployable as a workload, followed by the disciplines themselves. On the show floor, you're going to be able to see this in action. This week, in the innovation booth, when it opens tomorrow, we have a demonstration of a machine that's using an ASM IPC with a Logix workload, an open source ROS robot workload, and an open source camera agnostic vision workload, all running on that current ASM IPC. It's delivering incredible performance, including safety without compromise of the safety component. I encourage you to check it out when the show floor opens tomorrow.
Yes, I think this idea of workload is really important in our approach to SDA. Think about the evolutions that has happened in the IT industry, servers and everything, where it's not an application in a specific compute surface, but it's compute surface on one end and compute capacity on the application. And then this is deployed as an instant, as a workload. So that's exactly what we want to do. And in the two steps that you mentioned, Logix as a whole, as a workload, but in a step two, each discipline of Logix independently deployable as unique workloads, plus other things that we are going to speak about, because different industries have different needs. And the same architecture doesn't work for everybody. So let's look about how we are enabling this architecture flexibility and the unique specific needs of industry verticals, but also of some customers.
One of the key benefits of SDA is that we'll be able to tailor control disciplines, those we talked about and more, and form factors to industry-centric variations in ways we haven't been able to in the past. Let's talk about an example. Today in life sciences, industrial automation is used in pharmaceutical manufacturing in small to large bioreactors. With SDA, we'll be able to scale that up to industrial data centers where that makes sense, or scale it down to a tabletop bioreactor like you see on the screen for personalized medicine in a hospital, all with common development, testing, and validation processes. We're also working on enabling integration of disciplines more quickly by extending the ability to create them beyond our four walls to embrace all of you, our community of experts.
So, as I said earlier, we are looking beyond the virtual PLC, and I think you get the point right. It's not sufficient just to virtualize a component of the architecture, because you get the same things with, okay, maybe a little bit more optionality on the hardware, but it's really to look at the whole architecture. So, where do you see the role of the edge? You know, we speak about the cloud, we speak about control, and then there is the edge in between. So what is the role that the edge plays in all that story?
It's a great question, Cyril. You know, SDA is definitely more than a virtual PLC. You think about it, it's really all Logix. You know, Logix is a high-speed packaging machine. Logix in a line controller and a battery plant. Logix in a fleet-managed AMR like Matt talked about. Or Logix controlling an electrolyzer for green hydrogen applications. Logix in a data center that may be performing a sort in a distribution center. Or my favorite, Logix in a grocery store checkout lane like is back in my hometown. You know, really, Logix is at the edge of where the most critical decisions are being applied to manufacturing. And many of those adjacent spaces automation is used in.
And making the bridge between the world of on-prem and the world of the cloud, and having a continuity between both. So,
you know, Logix will be available in all these forms, whether it's virtualized, industrial PCs. These new forms we're calling Logix Edge. And you'll be able to see it as you navigate the show floor the next few days. But also SDA will be deployed in what you know as control Logix or compact Logix that have been in the market for a long time. It's really all Logix. It's important to note that the applications you've already created are very forward portable to these new form factors that are coming.
So, new principle on the system architecture, but more flexibility, more optionality, more choices can potentially mean more complexity, more things that needs to be done. So, how is your team thinking about tools, architecture, environment? You know, like I said at the beginning, embracing the best of those IT principles, because there is a lot of experience here, and bringing the best of those experience to the shop floor. So tell us what you and your team thinks about it.
So to manage the potential complexity that might be involved, especially at scale, we're really looking to leverage lessons learned from our colleagues in IT. And one of the things Blake said a little while ago is doing that in a simplified way. So in the early days, if I go back when I was a lowly field service engineer many years ago, the act of upgrading a control system involved double EEPROMs, a chip puller, ground straps, and a screwdriver. Many of you were there. I got pretty good at it. We moved on from that to Control Flash, kind of a software application that you use to deploy the functionality that rides inside of these control systems. Well, going forward, we're going to be moving to more modern IT tooling. The first place you'll see that is with our FactoryTalk Design Studio cloud-based environment that is going to gain the ability to connect to controllers this year. And then we're leveraging some of the openness that you see in the IT community today by leveraging, in this case, one of our partners, Red Hat, and their tool called Ansible. You're going to see two examples of this week. The first one is we're leveraging to deploy a new capability in Plant PX called provisioning and management. And in this scenario, we're leveraging the Red Hat Ansible tool to allow a person who's going to deploy a Plant PX system, and that's quite an endeavor today. You're going to go through basically a form to fill out what are the name of the servers, the IP addresses, what are the switch configurations. You're going to fill that information out, hit the green go button, go get a cup of coffee, and it's going to push it out to all those devices. A much more automated experience with traceability. The second place you're going to be able to see this in action this week is one we're really excited about. And it's that same machine I showed a little bit ago around Logix, or the SDA over in the innovation booth. And in this case, we're going to show a group of Logix controllers that is also on the end of an Ansible script pushing the new firmware into the control system. So there's a lot of creative things that we're doing here. And Cyril, we're changing the way we think, embracing new technology and leveraging lessons learned from many of our colleagues in other spaces.
And this idea of script, I think, is a good example. It's very powerful. Let's not redo the same thing all over again. Let's write a script, embrace those modern tools, which is something that is done in the IT for many years, and then apply it to our space for the benefits of the simplicity and the speed of execution.
Pretty excited about it.
So I want to emphasize again when we speak about SDA, you don't have to wait. Many of all those different things that we are discussing today are not a future dream. Again, even for SDA, those are real things that you can touch, feel, experience, and give us feedback. We will love to get your feedback and enrich your vision with your comment on that specific topic. I think it's a very important pillar for us to evolve our system architecture to be able to address all those use cases we have discussed about. So thank you, Don. Thanks for joining us today.
Appreciate it.
Thank you very much.
Thank you.
Thank you. So to wrap this up, and I know we have been a little bit over versus what was planned, so I'm going to close this so that I can free you, but thanks for staying here. So all this, again, right here, right now, when I speak about integrated robotics, artificial intelligence, software-defined automation, there is more than a V1 available, and there is a clear path to the future that we have identified that we want to share with you. So this is not just a vision, but this is our roadmap. This is a reality. This is where we put in priority our resources. And this convergence of advanced computing, AI, integrated robotics, this is what brings us to the inflection points that I was mentioning. It's not each of those topics in their whole maturity life cycle. It's the fact that they are all reaching a great level of maturity at the same time. And if we can pull them together, then we achieve what I was discussing. It's people and machine working together so that we can maximize the potential of industrial operations and people in industrial operation, which is what we are so passionate about. So we've created the vision, and we are delivering that vision. And it's our commitment to deliver that vision for you in this room and for our ecosystem. This is what we do, and this is what we are very excited about doing. And in this future of industrial operations that we are inventing and that we want to invent with you, we elevate human work. We align with what we do well, which is creativity. We move freely this idea of reinventing our business from industrial automation to industrial autonomy. And really, again, I'm repeating myself, but creating those synergy between people and machine to really reach a new level of industrial performance, really unlock a potential that is here, but needs new technology, new approach, and new mindset to be released and for the benefits of all the topics that you care about, whatever it is, empowering your people, driving better economic results, quality, safety, all those different agility, flexibility, all those dimensions. We are fueling what's possible with those technologies. This is what we are doing at Rockwell Automation, creating the future of industrial operation.